Download this code from codegive.com, link in the description below. Sure. Let's discuss Leetcode problem 1802, titled Maximum Value at a Given Index in a Bounded Array. This problem requires you to find the maximum value that can be placed at a specific index in an array while adhering to specific constraints. Problem statement. Given three integers n, index, and maxsum, you need to construct an array of length n such that the value at position index is maximized. Each element in the array must be at least 1. The sum of all elements in the array must be less than or equal to maxsum. Additionally, the value at each index must not exceed its neighboring values by more than 1, which means if you have a value at index, the values directly adjacent to it, both left and right, must be equal to or less than value and can at most increase by 1 from value to the next element. Approach. To solve this problem, you can use a binary search approach to efficiently find the maximum value that can be placed at the specified index. One binary search, the idea is to set boundaries for the maximum value at index. The lower bound can start from 1, and the upper bound can be maxsum. To check feasibility, for a mid-value during the binary search, you need a function to check whether it is possible to achieve this mid-value while satisfying the constraints. This involves calculating the total sum of the array formed by the value at index and its neighbors. Through sum calculation, you can calculate the sum of the elements on the left and right side of the index based on how far they can go while respecting the constraints defined by the mid-value. Code example. Here's a Python implementation of the above approach. Explanation of the code. One function can place value. This helper function checks if you can place the specified value at the index such that the total sum of the array does not exceed maxsum. To binary search, the main function maxValue performs binary search between 1 and maxsum. If a mid-value is feasible, using the canPlaceValue function, it tries for a higher value. If not, it reduces the search range. 3. Return value. Finally, the function returns the maximum value that can be placed at the given index under the defined constraints. Conclusion. The problem utilizes a binary search approach to efficiently find the maximum value while checking feasibility through careful sum calculations. This method ensures that the algorithm runs in logarithmic time with respect to the maximum sum, making it efficient even for larger inputs.